This is MathGuide.com. My name is Mark Karadimos. Today what we're going to do is talk about how to solve an absolute value inequality. So there are several steps in how to solve one. So I have a table that will indicate all the steps you need to follow. So before I continue with an example, I want to show you this table and show you that there are several steps in doing this. And one of the most important parts of solving an absolute value inequality, algebraically speaking, is getting the absolute value alone. Okay, that's the first step. You got to do that. Once we get the absolute value alone on one side, then all these other steps are going to follow from there, like changing the inequality to an equality. Then we're going to make two equations, which I call bifurcation. And then we're going to solve the two equations to get critical values. We'll plot those critical values in a number line. And then we're going to test a value that isn't a critical value, and we're going to determine if that value is true or false within the original absolute value inequality. And that'll tell us exactly where our solutions are on the number line. And once we get that graphical image of a number line, then we're going to convert that into inequalities. Alright, so we've got a lot of steps to do. Let's take a look at our first example. Okay, let's look at our first example. So for our first example, you could see that this is a relatively simple looking problem. There's not much happening. There's just an absolute value, an inequality, and some value over there. So the first thing I would do is get the absolute value alone. Well, it's already alone on one side. So the next step is I create an equality. So in other words, I don't change much except change this to an equality. The only time you really use the inequality is to determine where to shade on a number line, as you will see. Alright, so once we have this absolute value alone and an equality, now we're going to bifurcate. In other words, we are going to write this as two separate equations. So it turns out that all of this inside, it fits 9, right? If all of this stuff is equal to 9, when I take the absolute value, it'll still equal 9. If all of this stuff inside the absolute value is equal to -9, right? If everything is there and is a -9, when I take the absolute value, that'll also be equal to 9. So that's how I can bifurcate and split this equation up into two separate equations. Once I have those, now I'm going to solve them. So I'm going to add 3 to both sides. So I'm going to get 12, add 3 here. I'm going to get -6. Alright, now we've got our two critical values. So what we do is we then take our critical values and we graph them on a number line. So I have -6 is our smaller of the two, and I've got 12. So our original problem doesn't have equality, does not have equality, that is. So we will have open circles. So these are not part of the solutions. So what we want to do is now determine where do we shade. Now for these problems we either shade inside the two critical values or we shade outside. It'll become more apparent why this is the case in our next video when I explain graphically what's going on here. Alright, but just take my word for it. We're either going to shade inside or we're going to shade outside. So to determine which of these three segments or three areas, or I should say intervals, that are going to get shaded, we'll test a value. So I always like to test 0. 0 happens to be between negatives and positives, so I know 0 is over here. If I test 0, it's just really easy. So if you remember, when you test values, and we've done this with other graphing inequalities, linear inequalities, you plug that 0 in for x into the original problem, and what you do is determine, I don't know, is this true? So let's determine if this is true or false. So 0 minus 3 is -3. Take the absolute value of that, we're going to get 3. Okay, now we determine, is this true or is this false? Is 3 less than 9? It certainly is. So we know that's true. So I know now that this section is true. In other words, all of these numbers in this section are going to work. So that's why I'm going to shade this entire section. I will leave it up to you to check some other value over here like 13 or larger or 12.5 or whatever number you want over here, and it will not work in the original problem. Likewise over here, any number smaller than -6, if we were to test it in the original problem, it's not going to work. I'll leave that up to you to check. Alright, but once we find that true spot, I know I'm going to shade there. So either shade inside or outside. Alright, now what I want to do is write this as an inequality. So what I'm going to do is write this as a single inequality, a compound inequality, and this is the way it looks. So I want all the numbers that are between -6 and 12, and there's our answer. Okay, let's take a look at a harder problem, our example coming up next. Alright, let's take a look at a harder problem now, example number 2. Alright, this problem is a bit harder because the absolute value is not alone on one side of my inequality. So I need to get that alone. Alright, how do I do that? Well, to do that, I need to get rid of the 4 and I need to get rid of the 3. So to understand really what's happening here, there's a parallel that I can kind of show you. Imagine if we had a simpler problem that looked like this. And I said solve for y. Now this would be a very easy algebraic problem. So you can see what I'm doing is I'm just replacing this and you're kind of thinking of this whole thing as a variable in itself as like y. Okay, to do that, it'll kind of give you an idea of what's happening. So if I were to solve this, I would subtract 4 from both sides, right, to get the y alone, that is. I'm going to get 3y is greater than 21. And then, of course, to get rid of the 3, I'm going to divide both sides by 3. And I'm going to get y is greater than 7. Okay, well, it turns out I do the same thing here to get this inequality alone. I subtract 4 from both sides. Okay, so what do I get? I get 3 times this inequality. I'm sorry, 3 times this absolute value. And we're going to get greater than 21. Okay. Now what? We get rid of the 3. So we divide both sides by 3. And I'm going to get the absolute value of 2x minus 1 is greater than 7. So sometimes people, look at an easier type of problem, and that's called simplifying, and it's a strategy that math people use to kind of solve more complicated problems. Alright, I'm going to get rid of this stuff because it's going to confuse us, but I just wanted to show you how to get the absolute value of a loan. Okay, I'm going to delete this. Alright, according to the steps that we're supposed to do, now that we have the absolute value alone, we make this an equal sign. Okay, now, because the inequality is just used for shading purposes. Alright, now that I've got an equality, I'm going to bifurcate. In other words, I'm going to split this problem into 2 smaller, or I should say not smaller, but at least separate equations. One positive and one negative value. So the 7 changed from a 7 to a -7. Okay, now we solve. So I'm going to add 1 to both sides. So let's see, I get 8. I divide both sides by 2. I get my first critical value. Likewise here, I'm going to add 1 to both sides. I'm going to get -6. Divide both sides by 2. I get -3. And there you go. I get my 2 critical values. So once you find the 2 critical values, you plot them on a number line. So our smaller one is -3, our larger one is 4. I don't have an equality, right? It's just inequality. There's no equal sign there. So it turns out I use open circles. I would use closed circles if there was a greater than or equal to, or a less than or equal to sign there. Okay, anyway, now I got to figure out where to shade. I either shade inside or I shade outside. To figure that out, I'm going to test a value. And my favorite is always 0 because it's easy to use. So now we go back to the original problem and I'm substituting in 0 for the x value. Okay, now I just play cleanup. So let's see, 2 times 0, that's 0. 0 minus 1 is -1. So I got -1 inside the absolute value. So let's see, the absolute value of -1 is 1. So this is 3 times 1. So let's see, I get 3 plus 4, and I get 7. Now we decide, is this true or is this false? Is 7 greater than 25? So I'm a little sloppy here, going too fast. Is 7 greater than 25? You'd say absolutely not. It is not. So this section right here is false. So if this is false, you certainly do not shade false sections. We shade the opposite. We're going to go on the outside for this one. Okay, what does this mean? This means that we are shading on the outside instead of the inside. Now what I like to do is come up with an inequality that describes the outside sections of this line. Okay, so these are all the values that are smaller than -3. These are all the numbers that are larger than 4. Okay, so if they're smaller than -3, I put a less than. If they're greater than 4, I put a greater than sign. Okay. So there you go. And of course, when you shade on the outside, you put or, because you really can't satisfy both requirements at the same time. It's either numbers are less than -3 or the numbers are greater than 4. Alright, so that is our final answer right here. Okay, make sure you go back to mathguide.com, check out all our other videos, interactive quizzes, and text-based lessons. Take care.